Hi friends, I am Jomy Punalal. Today I am going to start a new series of classes on SageMath. Now our question is, what is SageMath? SageMath is System for Arithmetic Geometric Experimentation, and its short form is SAGE. And SAGE is a free and open source mathematical software, and one can say that SAGE is a sophisticated computer algebra system. So SAGE can handle numerical computations like symbolic computations, symbolic manipulations, graphing 2D and 3D, and of course programming also. SAGE is initially developed by Professor William Stein, and who was formerly at University of Washington. The first version of SAGE is released in February 2005. Now the current version is 9.0. The aim of William Stein is to create a viable open source alternative to the giant softwares like Magma, Maple, Mathematica and MATLAB. The mainstream programming language of SAGE is Python, and one can use SageMath as an advanced calculator. SAGE can handle complex numerical computations, and we can use SAGE to visualize, and you can create animations, etc. A very good symbolic manipulations in various branches of mathematics can be done. The main branches of mathematics like calculus, linear algebra, abstract algebra, number theory, graph theory, differential geometry, combinatorics, etc. And the very interesting thing is that all these are well documented in SAGE. Writing programs in SAGE is very simple. A little bit knowledge of Python is enough. SAGE can use to solve a lot of research problems, and learning SAGE, teaching SAGE and doing mathematics using SAGE will bring you to a next level of thinking. So with this introduction, let me start the class. First of all, you have to go to a website. This is our website, www.sage.org. Here we found all the stuff related to this SageMath. And if you are going to become a dedicated SAGE user, then you can download the SAGE to your system, and this top right corner you can see that the download button, there is a download button is here. So using that download button, you can download SageMath to your system according to your operating system, whether you are using Windows, Linux or Mac. So there is a step-by-step instructions are available for downloading SageMath in your system. And the very interesting thing about SAGE is that there is no need to install it in your system, and that's nice. And then how you use SAGE? The only thing you need is a good browser, just like Mozilla, Google Chrome, Safari, or you can use any of your favorite browser. So once you decide that you are not going to install SAGE in your system, then this web page will tell you two options. So that is, one is CoCalc and another one is the SageMath cell. So one is CoCalc and other one is SAGE cell. So these two are dedicated SAGE cloud platforms. So these two are the cloud platforms. So let me talk first about CoCalc. So CoCalc will help you to save your work for the future reference, and the only thing you have to provide is an email ID and a password to start the calculation. So just like you are using an email account. So that is the thing about SageMath, the CoCalc. So the CoCalc website will be look like this. So this is a dedicated server, acts as a dedicated server for CoCalc. So what you have to, first of all, you have to sign in. That is a one-time process. So you have to provide an email ID and you have to create a password also. So whatever your time you are going to use CoCalc, you have to enter into this website using sign-in option. So you can do all the calculations there. The second one is the SageMath cell. Here no registration, no email ID is required. The only thing is the browser. So you have to use your favorite browser for using the SageMath. So what you have to do is you have to go to SageMath, sagecell.org, or you can directly go from this website by clicking this Sage cell here. So the SageMath cell will do the same job, but it will, the work you will not, the whatever you are doing, so whatever you are writing is in this box. So your code will enter into this box. So whenever you close your browser, all the code will be disappeared, and there will be no saving options available there. So you can copy paste the code to a notepad before leaving the browser is a better option in this case. So whatever code you are written in this box, if you close the browser, then all the data will be lost. So you can do the calculation here and you can leave the browser. So that is all about how to use the Sage. So one option, CoCalc, SageMath cell, or you can download the version. Then the whole documentation will be available here. So once you go to the documentation page, you can see that all the informations about the Sage is appeared here, and you can access any of these tutorials. So introduction to the SageMath and detailed description about calculus. The complete documentation of calculus and plotting is available here. Algebra, number theory, combinatorics, and a lot of stuffs are available here. So you can give a detailed look at each and every sections, and it will be available in different languages in the form of PDF. So you can choose your language and you can choose the corresponding PDF. So these are the things required for starting SageMath programming. So without any delay, let me start our first class on the SageMath. So our first class deal with SageMath as a calculator. So I am downloaded the SageMath to my system so that the window will look like this. So here I am using Jupyter Notebook for doing my computation. So if you are using the SageMath cell, the same calculation will work there. The first calculation I have done is a simple addition. So I add these two numbers, and what I have to do is you have to type that numbers in this input box. So I input the second number. So this is our problem, and once I enter the numbers here and if you want to add, you have to use the plus button, and if you enter the code, and there are two options for running the code. One is there is a run button here. So once you press that run button, the code will execute. So and it will give you the result. Another button is if you are using laptops or computers, then there is in the keyboard you can press shift and enter. shift button and together with the enter button. If you are using the laptops, then you can or you can, if you are using the keyboard, then shift enter will do the same job as this run command. So if you want to change these numbers, so I want to do one more calculations, then I have to add 10 plus 5, then I am going to press the shift and enter key. So whenever I press shift the enter key, then the SageMath will give you the answer 50. So suppose if I want to change my calculation 10 plus 50, then SageMath will give you 60. So I am using for 5089, then I press the run button. That will also do the same job. So that's all about the addition, and the same way we can do this, the subtraction and the multiplication. In the multiplication case, you have to put the star button. Star button is reserved for multiplication, and for division you have to use this slash button. So the slash button will give you the division. So whenever you are giving this division, you will get this type of answer. Suppose if you are dividing this number with this number, then the Sage will give you another fraction. So that is the exact number equivalent to your computation. But you are not interested in this type of fraction, then you can use two methods. One is, I just copy the same calculation, here. You can use two methods. One method is, you have to make one number in floating form, so that will return you the decimal or the numerical approximate answer for this fraction. So Sage will always give you the exact answer. So according to the Sage, this rational number is the exact approximation to your input. So this fraction is the exact approximation. So Sage will always lead you to the exact number. So this fraction is exactly equal to this number. But you are not interested in this type of fractions. Suppose if you want the exact numerical approximation of this fraction, then you have to make one number in the form of a floating number, then you will get a numerical approximation. Or the other way is, you have to put a dot and n in open and closing bracket, then that will also return the numerical approximation. So the nice thing about this usage is, suppose if you are interested in the Sage will give you the first 15 digits of this approximation. Suppose you are interested in some more digits, like if you are interested in 50 digits, so n dot digits equal to 50 will give you the answer nearest to the 50 significant figures. The default will be 15. 15 is the default. So if you are putting the command like n dot open bracket, then that will give you to the nearest to 15. So if you are doing the same in the digits equal to 15, you will getting the same answer. So once you are putting it as 150, then the Sage will give you the digits up to 150. So this is the up to 150. So this is the numerical approximation. Suppose you are asking, suppose I am doing the same calculation. Suppose I am trying the same calculation in the SageMath cell. What I require is the internet connection. So I am connected to the internet. So I have a good internet connection. Then you have to make sure that you have a good internet connection. Then you have to put the same calculation in this SageMath cell box, and then what you have to do is you have to press this evaluate button. So you put the evaluate button, an answer box will appear here, and the calculation is going on. So that is the indication of, this is the indication of that the calculation is going on, and you are giving digits equal to 150. So Sage is calculating this fraction according to the 150 digits. So the answer is here. So this is 7.1000 up to 150 decimal places. So if you are using SageMath cell, a good internet connection is essential for doing very long calculations. So that is the only thing we have to make sure while you are using SageMath cell or CoCalc. The CoCalc is also same. If you are connected to the internet, then the result will came very fast. So okay, so with this introduction, so I am going to the some other calculations also. So what you have to make sure that whatever calculation I have done here, you can do the same in SageMath cell also. Whatever calculation I have done here, you can do it in the SageMath cell also. So if you are using your mobile phones, then in the mobile phone itself, you can take this SageMath cell and you can try it on your mobile phone also. So only thing is you need a good browser and a good internet connection also. For a very large computations, for a very heavy computation, you need a good internet connection so that your answer will be get fast. That is the only drawback when you are using SageMath cell. Good internet connection is required. So if you are going to calculate this 2 raised to 20, so the operator will be double star. So if you are going to calculate 2 raised to 20, then the operator will be double star. So if you are familiar with the Python, so in Python language, the operator will be double star. Okay, in Python also the operator will be double star. So we already told that the basic programming or basic code behind the SageMath is Python. So double star is the exponential operator in Python. So that same operator will works in SageMath also. But one more operator is also do the same job in SageMath, that is this caret symbol. So caret symbol also give you, I am pressing the shift enter button, so the caret symbol also give you the same result for 2 raised to 20. So in SageMath you have two options for exponentiation. One is double star and this symbol. That symbol is available in the keyboard by pressing shift and the number 6 by the numerical key 6. So that will give you this symbol, and 2 raised to 20 is calculated in two ways. So that's all about the power button. So you can do this as an exercise, 2020 raised to 2020. So it's a very big number, 2020 raised to 2020. So you can do it as an exercise for you. And one is what about the 2 raised to 25? You can do it. So how will you calculate the square root? So suppose I want to calculate this number. So the command for square root is sqrt, in brackets you have to put the number. So once you put the number here, I am putting 3 and I put shift enter, what the Sage will give you a square root of 3 itself. So Sage will not give you your expected answer. So we are expecting a numerical approximation of square root, but Sage will not give you the numerical approximation directly. Sage will give you the exact number equal to exact value of square root of 3. So square root of 3 is nothing but, in mathematics speaking, the exact value of square root of 3 is nothing but square root of 3. So if you need the numerical approximation of square root of 3, you can use the previous numerical approximation command. So that will give you 1.732050 up to, so the total digits will be 50. Suppose if you want to calculate the square root of 3 up to 50 decimal places, then this command will give you square root of 3 up to 50 decimal places. So this is the power of SageMath. So if you want to compute square root of 2, then the same command will work up to 50 decimal places, 1.4142 up to 50 decimal places. So from 41 to 69, 9 up to 9, there are 49 digits. And including 1, its total digits equal to 50. So that's about the square root. So the same will work for a bigger number. Square root of this will be equal to 87 and this number, and we have already told that digits. So how will you calculate cube root and something like the nth root? Nth root means you have to give the number n. So can you calculate the 2020, the root of 2020, or you can write cube root of 216. The method we can try is double star of the whole raised to 1 by 3. So in mathematics we can say that this root is equivalent to saying that the power is 1 by 2020. So here 216 the whole raised to 1 by 3 is equivalent to this number. So we can use 216 double star in brackets the whole raised to, the double raised whole raised to 1 by 3. Suppose I am trying the same without brackets. I am trying the same, I am not using the brackets. What happens is I am getting a different answer, 72. Can you guess what happened? You can pause the video and you can think that what happened to this calculation. So this is 216 double star the whole raised to 1 by 3. So 1 by 3 in brackets, and here 1 by 3 is not in brackets. So what happens? So in school mathematics we already told that if you have to do a calculation in a specific order, you sometimes use a rule called board mass, right? Bracket open, so division, multiplication, addition and subtraction. There is some rule. In computers also there is a hierarchy of operators. So whatever thing, there is a hierarchy in doing calculations in computers also. So the power, taking the power has the more hierarchy than multiplication, division, addition, etc. Suppose if you want to break the hierarchy, you have to use brackets. In order to break the hierarchy, natural hierarchy, so in the natural hierarchy is the first, in this calculation the natural hierarchy will be first goes to the double star. Then the computer will check if there is a division available there. First of all double star, then there is a division, and then multiplication, addition and subtraction. That is a natural hierarchy. So if you want to break that hierarchy, you should use this bracket. So once you use the bracket, so bracket will, whatever calculation in the bracket will done first. Then only it will move to the left side, and from left to right there will be the natural hierarchy. So what happens is, this has the natural hierarchy. So 216 raised to 1 is calculated first. So this I selected number is calculated first. So 2166 raised to 1 is nothing but 216. So the computer actually do this one, 216 divided by 3. That's why we are getting 72. Actually we required is 216 the whole raised to 1 by 3. So you should be very careful while using this type of calculations. So you have to put parenthesis before you are going to use this type of calculations. So here also you have to be very careful, because if you are not giving this brackets, the answer will be different. Now we are going to moving for introducing some inbuilt mathematical constants in Sage. One famous mathematical constant is pi, and pi is the value of pi is inbuilt in SageMath, that is in the variable pi denotes the value, this number pi. So whatever, if you put this pi and you enter, the Sage will return the same number pi, because say the exact value of pi is stored in pi variable. If you want to know this, if you want to know which formula or which way the pi is stored in the SageMath, because Sage is an open source software, so you can download the source code and see that which way SageMath is calculating this pi. So that is also available, but in almost all other softwares like Mathematica, MATLAB, Maple and Magma, that facility is not available, because you cannot access the source code of that softwares. But here, which way the Sage is calculating this number pi can be, you can verify how SageMath is calculated this pi. So here, suppose if you want the numerical approximation, you can use the very previous command .n. So .n can be used to find the numerical approximation. So without any argument here, you will get pi as up to 15 significant figures, or total 15 digits. So including the dot, you will get 15 digits when you are not using any argument here. Suppose if you do the argument as 150, so you will get 150 digits for this pi. So suppose if you want to get the approximation of pi up to 100 decimal places, then you can put the digits equal to 5, then this will give you the value of pi up to 99 decimal places. This selected numbers will be up to 99. Suppose if you want the 100 decimals, you have to put 101. So after 6 8 you will get one more approximation, that is 0. So now you will get 100 decimal places. The pi will be available in 100 decimal places if you put 101 here. So now the one constant will be this much. So E. So E is also, the value of E is calculated in this way, and you are getting E to be 2.718281 up to 15. And if you need some more digits, then you can use the command .n digits equal to your required number, so that will give you the. And one more constant is available in Sage is called golden ratio. So golden underscore ratio is the variable. So, and there is a number is stored in this variable. That number is nothing but that number will start with 1.618. And if you want that numerical approximation of that number up to 15 decimal, then you can use dot n, and you can use some more approximation 150 or 1500, and that is also available in Sage. So that is 1500 digits of golden ratio will be look like this. So that's very, and also we already know that we are all mathematics people, and we already know that what is golden ratio. So golden ratio is nothing but the ratio of two consecutive Fibonacci numbers. So in Sage we already we know that the consecutive Fibonacci numbers can be generated using the command called Fibonacci. So Fibonacci is a function predefined in Sage which will give you the 10th Fibonacci number, and Fibonacci 9 will return the 9th Fibonacci number. And if you calculate this ratio Fibonacci 10 by Fibonacci 9 up to 15 decimal places, and you are getting 16173, and it is nearly close to this number, because 61 up to 2 decimal places it was almost equal. Suppose if you put Fibonacci 100 divided by Fibonacci 99, so we can see what happens to this. So this will be exactly same. Suppose if I put 150, or I can put 100, so then that will look 100. So if you put 100, and if I take 100 by 99, so I have to run this, so I will get that, and I have to run this. So what happens? So if I check this numbers, this what okay, this up to, I think 5 and the note, okay, that's 13, okay, 772 up to 7720 is okay. So up to 7720, so up to this number, this predefined, the Sage golden ratio is similar to our computed golden ratio. This is our computed golden ratio, because we know that the golden ratio is the ratio of two consecutive Fibonacci numbers. So we take the ratio of 100th Fibonacci number to the 99th Fibonacci number, then you are getting this golden ratio up to this much digits. So if I increase if I am taking the thousandth Fibonacci number with the 999th Fibonacci number, then what you are expecting is you are getting a more approximation. So here also we are going to correct. So here we are getting the up to 100 decimals, it's okay. Up to 100 decimals it's okay. If I try with 150, if I try with 150, you can try yourself. You can try with 150 what happens. You can, here also we have to run again. So up to 150 also it's okay. So you can try with the 200, 300, whatever it may be. And if it's in some point, if we can, I am putting 2 zeros and I am putting 2 nines, and we can run the same, and you can that will a fraction of seconds is required to compute the 1 lakh the Fibonacci number to the 9999 Fibonacci number. So you can try your own, and I can use, so I will demonstrate the same in the, I can demonstrate the same in the SageMath cell itself. That will work here. So I put, so I am putting 3, 4, 5, 6, 7, 8, 9, 10, 11, 2, 3, 4, 5, 6, 7, 8, 9. So up to 150 decimal what happens? So this is a Fibonacci number. So the SageMath cell is working. So this rotation is the indication that the Sage is working. So the calculation is going on. So depends upon the internet connection, you will get the answer. So you can wait. So it's somewhat a heavy calculation for this SageMath because sorry. So the SageMath will give you, let's change the size, and SageMath will give you some error. So because I think it's a very heavy calculation for this much. So I am reducing the size. I have to reduce the size. 345. Okay. So let me try like this. Try this because okay, that's okay. That's computed. So I increase one more 0 and I one more 9. So let me try. So that's okay. This will work. Then 1 0 and 1 9. Let me try once again. So it also works. And finally our this message, maybe it will give you error. Okay, that's also work. Then I will increase one more 0. So what happens to this? So the 100 crore Fibonacci number with the ratio, and that also work. Maybe sometimes that maybe the internet problem is there, so that is why we are see an error before. So this number is also works very well. So this number is 100 crore. So 100 crore Fibonacci number, we are taking the ratio of the 100 crore Fibonacci number. We are taking the ratio of the 100 crore Fibonacci number to its previous Fibonacci number, so up to 150 decimal places. So you are getting the answer like this. So everything will be fine. So you can do the same job in your mobile phones also. So this is up to Fibonacci number. Now you can I think we can stop here for the first day.